Algebra uses a system of notation where letters represent numbers we don't know yet. Like the shifting parts of this puzzle, these symbols are part of a precise structure that follows a specific set of rules. To work with the system, we first have to break algebraic expressions down into their core structural building blocks. Next, we'll move into subtracting complex polynomials, focusing on the mechanical steps required to avoid common sign errors. Finally, we will substitute specific numbers into the expression to calculate its final numerical value. By following these 3 steps, we can take a string of abstract symbols and organize them into a manageable, solvable format. Algebraic expressions contain numbers, variables, and operation symbols, but they do not contain an equal sign. Within these expressions, variables are the letters representing unknown values, while constants are the fixed numbers that do not change. In 5a minus 2b plus 10, the variables a and b are highlighted blue. 10 is our constant, tagged green. The expression splits into distinct chunks called terms. The numerical factor multiplying a variable is a coefficient, here 5 and -2. Keep in mind a variable standing alone, like x or -y, has an invisible coefficient. It is treated as 1 or -1. Identifying these 4 parts allows us to accurately categorize the data before we begin any calculations. Subtracting algebraic expressions is the process of adding the opposite of each term being subtracted. To manage this for longer polynomials, we use the vertical method to align our terms. We place the starting expression on top, aligning the second underneath by exponents. You must invert the sign of every term in the bottom row. Now we add straight down each column to get 4x squared plus 5x minus 12. Pay attention to the phrasing. Subtract a from b means that b is your top row and a is the expression being subtracted. Using this sign inversion step prevents the most common errors when working with negative values in polynomials. To find the numerical value of an algebraic expression, we must physically replace each and every variable with a given specific number. When you substitute these numbers, always wrap them in parentheses. This is a vital habit for maintaining the correct signs, especially with negative integers. In 3a plus 2b, let's set a to 4 and b to -1. We drop the values into their places, using parentheses. Applying the order of operations, multiplication gives us 12 and -2. The addition step combines these into 10. Consistently using parenthetical substitution ensures the arithmetic stays perfectly accurate as you confidently move through the strict order of operations. We have now identified the components of an expression, allowing us to deconstruct them into variables, constants, and terms. We've used the vertical method to subtract polynomials by applying the sign inversion rule. And we've calculated the numerical results of expressions through substitution and the order of operations. Applying these specific mechanical steps to your own practice problems will help standardize your approach to algebra. Mastering these 3 protocols provides the consistency you will need when we begin solving for unknown values in equations.